Hey guys, I'm Mehrdad Basiri, and today I want to do and solve an interesting question for you. The question says that in the integral of tangent inverse of root 2x dx, what is the value of this? The value we can say. What is the expression that this guy gives to us? And the source of the question is from University of Sharif. It is from Sharif University, and I just find it so amazing and good question. We go actually and solve it, and you understand that why I am saying that this is good. Okay, let's go and see how should we solve this question. Okay, for actually solving and doing this question, at first I come and name root 2 of x, for example, z. Name that z. Let's go and name it root 2 of x. I call it z. Okay. Actually I change root 2 of x to the z, so dx should be something based on z. Actually it should be something like dz. We should get the derivative from both sides of this equation. Let's go. It is, why it doesn't draw. Okay. So the derivative of this guy is going to be 1 over 2 multiplied by root 2 of x, and dx, it means derivative from actually based on x, and this guy is going to be dc, and I want actually dx, so dx is going to be 2 root 2x dz. I come and put actually the new values instead of anything I have in this expression. Integral tangent inverse, I call root 2 of x z, and dx is this guy, multiply by 2 root 2 of x is z again, so I just write z and easy. So, and I just put this guy out of the integral, actually put 2, number 2 out of the integral. It becomes like 2 multiplied by integral of z multiplied by tangent inverse z, easy. Let's call actually this guy u, and this guy v prime. I want to use a formula that I would say the proof of that formula too. So I want to use this formula. Let me write it somewhere. The integral u v prime is u v minus integral u prime v. Okay, the proof of this formula, you should just get the derivative from both sides. Get the derivative from both sides. The derivative actually goes with the integral. So we will reach to u v prime equals u prime v prime minus u prime v, and I shoot this guy u prime v to the left side, and we will reach to, and I get a factor from prime here. I will write it u multiply v prime is going to be, it's going to be like this. Okay, and u prime v plus u v prime. This is actually the derivative of multiplying two expressions. So this formula actually is correct, and the proof of that is this. Get derivative from both sides of the equation. Okay, I call these guys actually tangent inverse z u and z as v prime. So I want u prime and v as well. U prime is going to be actually the derivative of tangent inverse is going to be 1 over 1 plus this guy here, z to the power 2, and the derivative of v is z, so v should be z to the power 2 over 2, that the derivative of this guy is going to be z. Let's go and use this formula here. U v prime, we should write equals this guy here, equals u v, where is u? This is tangent inverse of z equals v. Where is v? This is z2 over 2 minus the integral of u prime. Where is u prime? This is here, 1 over 1 plus z to the power 2, and v, this is this guy, and multiply by z2 over 2 dz, and this guy is okay. We simplify it later, but let's actually at first go and simplify this guy. And the integral, let me write it somewhere. I think I should clean this guy. Let's write it now. Z was root 2 of x. Tangent inverse root 2 x, and root 2x to the power 2 is going to be x, and it's going to be x over 2. But how about this guy? I just want to clean here this. Actually, guys, just remember them. Don't forget. And this formula, I just explained it. So the integral, these two guys multiply with each other. I just put 1 over 2 outside of the integral, because it's not important, it is minus 1/2, and multiplying these two guys is going to be z2/1 plus z2. Easy. Let's add and actually subtract 1 here. Plus 1 and minus 1. z2 plus 1. Easy. I just want to make these guys separate. I mean like this. See? And these is for both of them, not just one of them. Okay, I just separate them, and this guy is going to be 1, and now we want the integral of dz minus integral of, this is for both of them, minus 1/2 is for both of the integrals. Wait, yes, 1/z to the power 2 plus 1. And this guy, actually, this integral is tangent inverse of z, this. And this guy, we can just simplify the integral and the derivative. And we're going to have minus 1/2z minus with minus is going to be plus, actually positive, and the integral of this guy, I said tangent inverse of z. So, and we will reach to, I write it like this, and what was z? Z was √2 of x. So let's just write it and finish this integral question. Over 2, I write this, minus √2x over 2, and I said this is for both of them. I just don't write it for this. So, and plus tangent inverse √2x over 2, and plus c if you want. C is a constant, otherwise it's not so important. So this guy here, actually you can see this expression is the integral of this guy, tangent inverse of √2 of x. And just, we shouldn't forget this 2 that is here, this guy, and this 2 is for the whole integral, so we should just multiply these 2. I don't know why it doesn't draw. Multiply these 2 by whole of this guy. That's, these 2 goes with each other, and in the end we will reach to, actually with simplifying, we will reach to this guy that I'm going to write it now. x tangent inverse root 2x minus, I just forgot that, minus root 2x plus tangent inverse yes, plus tangent inverse root 2x plus c. This is constant. And yes, so this expression is actually the integral of this guy that you can see. And this was the question of today. Okay guys, this was the question of today. Thank you for your watching, and I hope you enjoyed that and it was useful for you. And if you like the video, please like and subscribe our channel and hit that bell that is next to the actual subscribe button, I think, yes. And you're going to be the first one who is going to see our videos when we upload the new videos. And yes, comment actually if you have something, suggestion, or comment something. Yeah, if you have these things, please comment and actually questions. And as usual, I wish you the best thing, and until my next video, bye bye.